Perfect. Okay, hi everybody. Like Joey said, my name is Zoe Brumbaugh, and I was one of the Scientists and Parks Ecology Assistants at Acadia National Park this past summer, so it's summer of 2024, where we did a lot of different intertidal work that I'm really excited to share today. I'm going to focus most of the presentation on what I like to call the lessons from the mud that I learned, but also talk a little bit more of our general experience as SIPs this summer. To introduce myself just a little bit more, I'm originally from Santa Rosa, California, so in Sonoma County, which is about an hour north of San Francisco. I graduated from UC Davis last June with a degree in marine and coastal science and an emphasis in marine ecology and organismal biology. And I grew up really loving tide pooling, intertidal invertebrates, going into the rocky intertidal zone, and I grew up loving going to Maine. So when I found this Acadia position on the SIP website, I was ecstatic, and it ended up being just a really amazing experience. So I'm really excited to share with you today. Another really important person I'm going to introduce before getting started is Stephanie Letourneau, who's actually on this Zoom right now too. She's a current master's student in her second year at the Virginia Institute for Marine Science, and she was my co-SIP for the summer. So there's two ecology assistants in Acadia, and Stephanie was the other one with me. And so all of this that I'm going to be presenting on today, we worked on alongside each other. We looked a lot like this picture in the bottom right next to each other. She was the best co-intern or SIP that I could have had, and I'm really thankful for her and just wanted to point out all this work we did side by side. And then I wanted to introduce one other thing before I get started too, and that's Acadia National Park. Just in case anybody here is not familiar with Acadia or where it is or what it looks like, Acadia is way up there in Maine, and it's a really beautiful, amazing park. People like to say it spans from seas to trees. It has miles of beautiful coastline, lots of beautiful forest. I would definitely recommend going there if you ever have the chance. And it was a really beautiful place to work. And then specifically within Acadia, Stephanie and I were kind of stationed at the Schoodic Institute, which is Acadia National Park's primary research and education partner. Our supervisor, Hannah Weber, is the director of marine ecology here. This is where Stephanie and I lived and worked most of the time within the park. So if throughout the presentation I refer to Acadia or Schoodic or anything like that, they're kind of transferable in my mind or how I'm talking. They're kind of the organization we were talking or working with. So to actually get into a little bit of the work that we did this summer in the mud, first is when we were in the mud, we were studying two species of marine worms. The sandworm on the left, Alitta virens, and the bloodworm on the right, Glycera dibranchiata. I want to point out here that these colors, green and red, are going to follow these worms for the rest of the presentation. So I'm giving you a little bit of a primer for them here. But a little bit about these worms, because they're pretty cool, actually. Both can be quite large. So sandworms can get up to 90 centimeters or 35 inches, and bloodworms can grow up to 37 centimeters or 15 inches. They're both venomous. They both have fangs, which can lead to some interesting moments in the field. And they're also both semilparous species, which means that their reproduction requires their own death, which also means that any worm that you find alive in the mudflat has not yet reproduced. They're really important players in the mudflats as ecosystem engineers, as important members of predators and prey, but they're also really interesting to study because they're actually a harvestable resource in the state of Maine and in Acadia National Park. So Maine is one of the only states in the country that has a marine worm fishery. It brings in a revenue of about $6 million every year, and almost 90% of bait worms for the country come from Maine. So there are a lot of worms coming out of Maine, and worming is actually the fourth most popular fishing license that you can get in the state. So there are hundreds of wormers in the field every day. And some people take their entire livelihood through fishing for worms. So it's a really important harvesting field in Maine. But unfortunately, both the populations of the sandworm and bloodworm have experienced a pretty significant population decline over the past several decades. These graphs on the right are landings graphs, so that means the amount of worms being sold into the market. The gray bars are pounds of worms sold. And you can see that for both sandworms and bloodworms, there's been a pretty significant decline since about the 60s or 70s, which is unfortunate both for the ecological systems that they inhabit and for the people that rely on them for their livelihood. I wanted to give people a little bit of a visual of what it looks like to harvest worms, just in case you weren't familiar with this before. But wormers go out into the mud flats with a worm rake and a bucket. All harvesting is done completely by hand. And the harvesters go out with their rake and they kind of dig it into the mud, and then they flip it back to unearth all of the mud underneath and unearth all the worms that live in that mud. And then they'll pluck them out with their hands and put them in their bucket. They'll move along raking kind of in 1 meter wide strips and then keep going forward. So when you look out at a mud flat that has had wormers there, that tide cycle, you'll see these strips of unearthed and kind of tousled around mud. And that's what I'm going to be calling worming strips for the rest of the presentation, because we'll talk about that a little bit later. So this is the moment when I'm telling people about this project that I like to kind of take a moment of candor and say that when my supervisor Hannah sat us down on my second day on the job and explained this project, I was like, wow, like worms and mud, not necessarily my two favorite things. I maybe could have been described as less than thrilled, which you might be able to garner from this picture that Stephanie took of me on our first day out in the mud looking for worms. I would say maybe this is a look of disgust on my face, but I was maybe, we'll just say less than thrilled, but I was still ready to get to work, maybe not as enthusiastically as one would like. But a lot of those emotions of mine changed when I met somebody named Fred, who is pictured right here. This is Fred Johnson. He is a commercial worm harvester in the Acadia area. He's been worming since he was 7 years old and has now been worming for over 60 years. He was an indescribably valuable resource for Stephanie and me over the summer as both a community partner and a research associate for us at Schoodic. And I really like to call him our liaison to the mud. He taught us almost everything we knew, everything from what type of worm is this to how to clean our boots off at the end of the day. So it was a really valuable experience getting to work alongside him. And we got to do a couple of cool projects working in collaboration with him that I'll also share about in a couple of slides. So to give a little bit of a framework of what the rest of the presentation is going to be about, I'm going to primarily, like I said, focus on these mud projects. First, our studies of size population structure at sites across Acadia, and then also those projects that we worked on alongside Fred. Some of my takeaways from this work, and then I'll do a brief overview of some of our other projects from the summer because we did not spend all summer in the mud. It was actually only probably about half of our work, and we got to work on some other really cool projects as well. But to start with our studies of the worms in the mud, we were doing surveys at 7 different sites across and around Acadia. So we had 3 sites at Thompson Island, 1, 2, and 3, and these are titled Thompson Good, Thompson Medium, and Thompson Bad. These titles for the sites were determined through conversations with wormers about kind of sites that were historically good for worming or maybe historically bad for worming. Then we have site number 4, Hadley Point, number 5, Otter Creek down at the bottom of Mount Desert Island, and then 2 sites over to the right at Fraser Point, 1 inside and 1 outside of the causeway. At each of these sites, we would do a protocol of coring that was adapted from the Maine Department of Marine Resources protocol, where we would take a 5-gallon bucket that had the bottom cut out of it. We would press it into the mud as far as it could go until we hit a kind of clay layer. We would measure the depth at that kind of clay layer, and then we would dig out all of the mud that was inside of that core and plop it into that mesh tray that you see on the right. Once it was in that mesh tray, we would sort through all the mud by hand to find even the teeniest, tiniest little worms that we could, and every worm that we found, we would take its length. We would do this for a 4-hour tide cycle, so 2 hours before and 2 hours after low tide. And our pace ended up being about 25 cores per tide cycle. And by the end of our data collection, we would shoot to have 50 cores per site that we went to. With this data of the worms that we found and how big they were, we were hoping to build population structures of what we were seeing at each of our sites. And if we were finding a healthy population structure, this is what we would hope to find. This is kind of the ideal state. So on the x-axis, we have count or number of individual worms. On the y-axis, size, so getting larger as you go up. And the green and the red, again, are for sandworms and bloodworms. What we would ideally look for in a healthy population structure is something that looks like this, where you have lots of small individuals or juveniles, and then there's kind of a natural progression of there's die-off as these things get older and larger, but you're still maintaining a population at each step of the way with that natural die-off, but still some survivors. So that's what we would be looking for if it was a healthy population structure. But to look at what we actually found, to introduce you to this graph really quickly, colors are the same. X-axis is the same, 2 worms per core, so that's our count. Y-axis is again worm size, anything from less than 5 centimeters to greater than 20 centimeters. And there's going to be 7 graphs on this upcoming slide, and each of those is going to be one of our sites that we studied. And what we actually found, I don't know about you, but I don't think it looks like a whole ton of perfect pyramids on this screen. But in general, some sites just don't have very many worms at all. If we see Thompson Bad in the top right corner, it lives up to its reputation. It is not a good worming site. We do not find very many worms. And then at many of the sites, we find disproportionately small worms. So lots or more in the less than 5 category, some in the 5 to 10 centimeter category, and then very few as we get up into the larger sizes. So this is something that we were thinking about both in terms of our protocols, but then also in terms of the populations that we were seeing at these sites. Now, the protocols that we followed this summer were also followed by the Scientists in Parks interns the previous summer in 2023. So we thought it would be interesting to look at some comparisons to their findings. And most of the sites we found pretty similar things, but I'm going to highlight 2 sites where we saw a little bit of a difference. So for this graph, we have worms per core again on the x-axis, but now the y-axis is going to be year. And the 2 sites that we saw the most stark differences were at Thompson Good and Thompson Medium, where in 2023, the Scientists in Parks ecology assistants found quite a few worms at Thompson Good and not very many at Thompson Medium. But this summer, we actually found kind of a reversal of this. So a decrease in worms at Thompson Good, especially in the bloodworms or the pink, and an increase in worms in Thompson Medium. So we thought this was pretty interesting, could maybe be a sign of differential recruitment or some impacts of worming, since Thompson Good is a very popular worming site. Then that's kind of where our surveys of the different sites. But as we were going out, like I mentioned, we found a lot of very small worms, not very many large worms. But when we were going out with Fred, Fred would be worming, doing his harvesting, and would be sometimes pulling out tons of large worms. And we would be like, Fred, how are you finding these? And it comes down to the differential in our methods, right? Our cores are really good at finding very small worms, but they don't cover up very much space or volume of mud. And the strips that Fred digs covers lots of volume, and you can really find the large worms, but there's not really any chance that you're going to get an accurate count of small worms in those spaces. So we were really interested in coming up with a protocol that could relate the 2 methods to kind of harness the best of both worlds. And how we started trying to come up with that protocol was conversations with Fred, going out with Fred into the field, asking him a lot of questions, things like, Fred, why did you choose to worm there today? Or why are you using that rake? Or what are the characteristics of sediment that you frequently find worms in? And after a lot of those field adventures and questions, what we ended up settling on is a protocol that looked a little bit like this, where we would go to a harvestable site and set out with flags a zone of 15 meters by 15 meters. In that zone, we would have Fred dig 2 3-meter long strips. He would pull out every bloodworm that he found, and we would measure it. And then we would perform our own cores 1 meter away from the strip and do 6 of those, 3 on each side per strip. So trying to kind of combine those 2 methods. We completed 2 sampling days of this, There were a couple of snafus during those sampling days, so it was pretty preliminary, but we would be really excited to see how this could continue on into the future and kind of be expanded in this way. Working on this work and doing work from a little bit more of a community science standpoint and working alongside Fred taught me a lot. And I had, I think, a lot of pretty big takeaways in my brain by the end of the summer that I would really like to share. The first one being that worms weren't really too bad. I really did grow to love them. They have some really beautiful colors. They can be iridescent in the sunshine. They can have their own personalities. They're really quite fun. So that was a nice takeaway that I wasn't really expecting to have. The second takeaway that was kind of reaffirmed to me was the importance of capturing and considering local knowledge. So Fred has more than, like I said, 60 plus years of experience in the region, and he holds an immense amount of anecdotal information about what worm populations have looked like over the past decades. And I think it's really important to harness this type of information, especially now as we face a future that is likely to experience more and more environmental change, where this knowledge could be really important and insightful and helpful. Another big takeaway that I had that kind of goes hand in hand, but is a little bit different, is the value of dialogue, and particularly dialogue that is a two-way street. I was always really impressed with the reverence in which Fred talked about park officials and park employees that took the time to sit down and have conversations with him, even if the conversations weren't always that they agreed on everything, but just the conversation itself has a big impact. And I think in the world of science and science communication, we talk really frequently about science communication in a way that is scientists need to be better at sharing what they're studying, at sharing their findings, and that is really incredibly important. But I think the other part that is equally as important, if not more so, is also being really good at listening and at listening to the communities where you are studying your study sites or that are affected by the things that you are studying and engaging in that conversation. Because ultimately environmental protections are going to require buy-ins from all partners, and having conversations is a really great way to help start to build those partnerships. And then the final thing that I thought a lot about during our worm work this summer was kind of conservation by use and preservation. I think in my past, I've been able to sit in a bit of a bubble and take a pretty strict preservationist perspective with kind of the thought that humans are just the worst for nature. The only good thing we can do is leave it alone. But this summer I got a really interesting viewpoint into interactions between humans and the environment, and how people can really care about a natural system and land and still use its resources and the ways that those can interact together. And it a bit reshaped the way I think about these things in a way that I'm excited to take into the future. So that's a little bit about our time in the mud. I do just want to share a little bit more about what Stephanie and I did for the rest of our summer, because we did get to do, like I said, a lot of really cool projects. Another main part of our summer was developing new citizen science projects to study the intertidal zone in Acadia National Park. Acadia has visiting Earthwatch teams that range from high school to retirement age, with people who come to do citizen science projects in the park. So we wrote 2 new citizen science projects in the intertidal zone, one studying sea star abundance, which is what these high schoolers here on the left are searching for, and one studying intertidal bird use of the intertidal zone. Both were really cool and a really new experience for me to kind of take these projects from start to finish. If you are interested in the world of citizen science or participatory science, I'm going to direct you to 2 articles written by 2 really fabulous scientists in parks. One is written by Stephanie. This is her article. Stephanie has extensive experience in participatory sciences and wrote this great blog post detailing a little bit of our work and work she's done in her past. So there's a QR code for it there. And then another scientist in parks, Nina Foster, who was also at Acadia this summer as the science communication assistant, wrote this really cool article, From Idea to Implementation, the Making of a Citizen Science Project, where she got to follow Stephanie and me along as we developed the whole thing. She came out into the field with us and it ended up really cool. So QR code for that one here. I can also drop the links for both of these articles in the chat at the end. I have not at all enough time to talk about them, so I really recommend checking these out if you're interested in them. Stephanie and I also got to lead the Dragonfly Mercury project in Acadia this summer, which was cool for me because it was kind of my first experience with aquatic macroinvertebrates, something I never thought I would do, and another really cool participatory science project. And then another thing that was just kind of an added benefit of this summer was I got to go out on a lot of different field forays, that I call them, to see what colleagues and what friends were working on, and seeing all these different projects that were happening throughout the park. So things like ocean acidification sampling, Project ASCO, Jonah crab monitoring, amphibian crossings, bird RAUs, and summit restoration, that really exposed me to a whole new world of science that I had never had experience with before. That was really cool to see. And then I would be remiss if not to talk about perhaps one of the best things about the summer, was that it introduced me to a group of about 14 other young people who care about nature and about the environment in one way or another, even if we're in all different types of positions. And they were a really amazing community of people to live with, collaborate with, and just spend a summer with. So I think some of the coolest things about positions like scientists in parks that get you out into the outdoors is the other people you run into on the way. So I really have to give a big shout out to the Schoodic ECPs, a couple of whom I saw are on this Zoom. And then finally, lots of people to acknowledge. I do want to acknowledge that the research that we did and where we lived was performed on the homeland of the Wabanaki people of the Don. And I owe a lot to all of these people and organizations that helped make this position possible and helped make the summer so great. And then with that, I'll leave you with this picture of one of my favorite spots in Acadia, and would be happy to answer any questions that anybody might have. Thank you.
Thank you so much, Zoe, for that informative presentation on worms. Now we have time for any questions that anyone would like to ask. You can either say it in the chat box or raise your hand. But yeah, I have a question, Zoe. Do you think that your experience with working in field has made you want to pursue a career in the future for more in-field, or has it changed your perspective at all?
It definitely has reaffirmed that I love being in the field. If I could have a job that was 95% outdoors, that would be kind of my sweet spot. So I really loved how much time we got to spend outside. It does test you at sometimes, right? Like 5 hours in and you're covered in mud. But it really did, I think, reaffirm that I do want to continue pursuing roles that have a lot of time in the field.
Perfect. Thank you, Zoe. And we have another question, I think from Leah.
Yeah, hi, this is Leah Flake. That was a great and really informative presentation, Zoe. Thank you. My question was, I was wondering, did you have any positions before this that kind of got you into conservation, or was this your first one out of college?
This was my first one out of college, and my first one with a conservation focus, I would say. I had some positions in the past that were actually in the mud and doing kind of more research projects in the mud, but not as much from a conservation view or yeah. So this
Great.
was kind of my first one with conservation. Yeah, sorry.
No, you're good. Awesome. Thank you for answering my question.
Mm-hmm.
Perfect. And I think we can answer one more question if anybody else would like to ask one. Oh, I think we have one on the chat. Sarah says, fantastic presentation. When you worked on bringing Fred's methods to your bucket sampling, was there much discussion about whether that way of choosing sites introduced bias, or if it did, if that effect on the worm count was desired?
Yeah, that's a great question. It definitely, right, it was not a random sampling. We were looking at where Fred was himself picking where he thought would be a good worming site, and we were interested in kind of then framing that comparison towards that. So saying if we had wormers out in the field that were worming where they like to worm, kind of what would the comparison be in those situations? That was definitely a part of it, that it was where wormers would worm. It wasn't if we were at any site and doing these protocols, because if wormers don't like to necessarily dig where they're not going to find worms. So we knew it would introduce some sort of bias, but that was an intentional part of it as well. That makes sense.
Mhm. And I think we have one more. Finn says, I agree about how scientists need to improve their outreach. Do you think an opportunity like this could help someone with the field or of scientific journalism or community outreach?
Yeah. Finn, do you mean this specific position or just positions like this? Or I will just answer for both. I think this position for me really helped. Oh, SIP internships in general, I think absolutely. I learned a lot about community outreach and engagement and communication this summer. So I think absolutely it helps with those fields.
Perfect. And I think that might be all the questions. So yeah, if everybody would like to give Zoe a virtual round of applause, that'd be great. But yeah, if you would like to host your own Brown Bag Science Talk, please don't hesitate to contact us at sipengagement@usa.org. You could either be a current intern or also an alumni. Also, applications for summer positions are due by January 19th. So if you'd like to apply, check out the website for Scientists in Parks for more information on how to apply. And don't forget to check our YouTube channel to rewatch her presentation or check out our past ones. But yeah, thank you so much, Zoe. And I hope everybody has a nice day and a really nice week. It's really cold where I'm from, so I hope everybody stays warm.